cosine functions. All right, so the very first thing we need to talk about are waves. Okay, now obviously we know that cosine and sine functions move in waves. Okay, so a single wave of the graph is called a cycle. All right, and the length of each cycle is its period. So this would be a period of 2 pi. Okay, so every time it repeats itself, it's 2 pi units. So fairly straightforward. I don't know that there's anything else we need to talk about all that other than the period is 2 pi for a sine wave. It is also 2 pi for a cosine wave. All right. You just notice. I just want you to pay attention to the features of the sine wave or sine period. Okay. It starts at 0, ends at 2 pi. It can also start at 2 pi, end at 4 pi, and so forth. Okay. It starts halfway through. It's between its minimum and maximum. All right. It rises. It starts halfway through. It rises to a maximum and falls to a minimum. So a lot of this is like conceptual knowledge. Okay. So let's talk about the cosine graph. Okay, what it does. Okay. It also goes from 0 to 2 pi. It starts as its maximum, okay, and falls to its minimum, and ends at its maximum. Okay, that's an important distinction. And also its cycle is 0 to 2 pi. Okay, so finding period of sine and cosine. All right, because what we're going to deal with is different functions. So it's not always just going to say sine of t. It's going to say sine of 7t or sine of half t or something like that. So you have to be able to identify the period from the function. These are very nice. They follow very easy formulas. Because this is so late in the chapter, I will probably give you these formulas on the test itself. So this I will give you, because you'll need period and amplitude. I think that's all you need. So, but yes, I will give you those. So here we go. So f of t equals sine of bt, or g of t equals cosine of bt. B is the number that we need to worry about for the period. Okay, you'll notice here its period is 2 pi divided by b. So most of the time, if we have sine of t, it's 2 pi because it's 2 pi over 1. Right? So then a period, if it were sine 2t, the period would be pi, meaning that it would take, the whole cycle would happen from 0 to pi. All right, so let's talk about the period of each one of these functions. Okay. So cosine of 3t, it is 2 pi divided by 3. So the period is 2/3 pi. So that means that it takes, the whole cycle will happen from 0 to 2/3 pi. Okay. And this one is sine of t over 2. This is an interesting one as well. This one, so it's actually like 1/2 t, so the b is 1/2. So it's going to be 2 pi divided by 1/2. All right, now if you remember your fractions, okay, this is the same thing as 2 pi times 2 over 1. Okay? What I'm saying, what I'm writing are two different things. 2 over 1. So this is actually 4 pi. So this is a very much longer cycle. Okay, it will do the whole cycle from 0 to 4 pi. So originally we would have something like this. The sine would go from 0 to 2 pi. This one is going to stretch like that. All right. So I don't, and in any of these, I'm not asking you to graph pictures. You're just determining the functions themselves. Okay. Period of tangent is pretty basic. It's just it's pi divided by b. So remember we talked about the period before was 2 pi. This one is pi divided by b. So again, these formulas, I will give these to you. So let's go ahead and do an example with the tangent. Okay, so if we have tangent of 2t, it's pi over 2. All right. And then tangent of t divided by 3, remember this is like 1/3 t. So it's 3 times, not 3, it's pi over 1/3, which is the same thing as 3 pi. Okay, I did not do the work there because this is fraction stuff that you should know how to do. Okay, next. Okay, amplitude. Amplitude, now this is where we're talking about vertical stretches, and it was really confusing because we didn't have these formulas, okay? So amplitude is the number that sits in front of the function, okay? And amplitude is the absolute value of the number that's in front of the function. So if this has a vertical stretch of 3, that's the amplitude. That means how tall it is above, not necessarily above the 0, but above the starting point. from its midway point. So anytime we have, and I can do this way too, okay? This would be considered the midway point. So how tall it is this way and how tall it is that way. So this one, the amplitude is A, okay? Now, if there's a negative in front of it, the negative means it's a reflection, so it really doesn't affect the amplitude itself, so it would still be the absolute, that's why it's the absolute value rate. So the amplitude is distance, it's how tall it is in both directions. So just a reminder here, so amplitude of A, absolute value of A, periods are 2 pi divided by B. So a lot of these questions will ask for both the amplitude and the period. If it'll say something like, give the amplitude and the period if applicable, okay? So obviously with the tangent function, we won't have an amplitude because it goes like this. It doesn't have an amplitude, you can't state that. So you won't, when it asks for that, you won't state the amplitude, you only state the period. All right? And remember the period of tangent function is pi over b. Okay, so let's look at this function. It says determine the amplitude of the period. Oh, we are graphing. I didn't realize that. But that's okay, we can do this. Okay, determine the amplitude and period of f of t equals negative 2 sine of 4 of t. Then graph on the interval from negative pi over 2 to pi over 2. So let's go ahead and determine the amplitude. First of all, the amplitude is the number that's sitting in front of the function. So a is the absolute value of negative 2, which is 2. Okay, and then the period is 2 pi divided by 4. So our period is going to be pi over 2. So this is going to be a very tight period. So actually, if we look at, so if the whole cycle goes in pi over 2, from pi over 2, from negative pi over 2 to pi over 2, it's actually going to cycle twice. Okay? So let's look at how we would graph this. I'm going to go here, 0. Okay, and I'm going to go ahead and put negative pi over 2 here, and pi over 2 here. Now, when you talk about the fact that it's, first of all, it's inverted, so instead of going, instead of going this direction, so instead of going up and down, we're going to be going down and then up. So now the other thing we need to pay attention to is that it's going to period as 2 is the amplitude. So this is 1, 2. Here's my 1, 2. All right. So what I need to do is I need to go up to 2 and down to negative 2 and then back up to 4. Up to 0. This, oops. What did I say? It's inverted. So we do need to go the other direction. So we're going to go down, up, and over. Continue this way. Okay. So there is my graph. Now I want to show you the difference between this and the normal graph, right? The normal graph cycles every 2 pi. So here's 2 pi, here's pi, and this is 3 pi over 2. Okay, now the normal graph would go to 1, so it would go like this. Do you see the difference? So I just wanted to show you that. It didn't ask you to graph both of them, but I wanted to show you the difference between the graphs. So, all right, let's do a couple more examples. All right, so we're going to state the amplitude and period of each function, but it didn't ask us to graph. I was thinking we needed to graph. That will be the next example. So let's go ahead and do this really quick. Okay. So first of all, the period of this function, there is no number in front of the t, so the period is 2 pi. Okay, and the amplitude is 1. That's the value of negative 1. Okay, this one, our period is 2 pi over 2, so it is just pi, and our amplitude again is 1. Fairly simple. All right, and a lot of your questions on your homework will ask you that specifically. All right, this is graphing. So we're going to describe the transformation of the graph, and then we're also going to change. So we're going to graph both of them, and let's see, does it say state? Describe the transformation that changes, state the amplitude. Oh, I guess no. All right, so the amplitude, first of all, it's a vertical stretch. Thinking we were graphing here again. Vertical stretch of 5. Okay, so the amplitude is 1. No, it's not a vertical stretch. Hold on. Because the 5 is inside of them. So let's start again. Let's look at amplitude is 1. Okay, and then my period 2 pi over 5. So what's actually going to happen is that, and I want to talk about this not in terms of vertical stretches or horizontal stretches and whatnot, but the idea of if my period is 2 pi over 5, that means that my graph is going to be much narrower than it was before. Okay, so if my original graph went like this, my new graph is going to be very short, the cycle itself. So it's actually shortening the cycle. So this number here will, it's actually a horizontal stretch. It horizontally shrinks it. Okay, so that's what that number does. You can talk about it in those terms. You can talk about the fact that the period will be much shorter. So you can say it squishes the graph. You can say it shortens the graph. It's whatever you want, however you want to talk about it. You can also say it's a horizontal stretch. Because even though it's shrinking it, it's still considered a stretch because it's a fraction. Okay, moving on. All right, this one, sketch. Here we go, sketch the graph. All right, so we have, let's first of all talk about the amplitude is 4. So this is going to be a very tall graph, and my period is 2 pi over 1/2, which is 4 pi. So this is going to be, first of all, much taller than before, and it's also going to cycle much longer. So let's go ahead and we'll draw, so we're just going to one cycle. So I'm going to go ahead and do, put these in here, pi over 2, pi, 3 pi over 2, 2 pi, oops, 3 pi, and 4 pi. Okay? And we'll go 1, 2, 3, 4, 1, 2, 3, 4. All right, so let's look at how this is going to work. So first of all, we know that it's going to start up here at 4 because it vertically stretched. Okay, so it's going to be 4 units between the top and the middle. And since we are now over a period of 4 pi instead of 2 pi, originally this would come down and intersect with, hold on, I lost my train of thought. Okay, this would normally, sorry, I lost my train of thought, let me clear everything. All right, so this would normally, if it were at 1, it would come down and it would intersect with pi over 2, and then would intersect with pi over 2 and then come back up. So now what it's going to do though, because we've stretched it by a factor of 2, we're going to cross over at the pi. Right, and then we'll have, it'll go under 2 pi here, and then I'll cross back up over into 3 and stop at 4. Okay, now some of these are going to be kind of tough because you have to think about what's the factor that I'm going by. Okay, this was a factor of 2, so I need to physically stretch it out by a factor of 2. Play with it a little bit. Can't quite get it. It'll come more naturally the more often that you do it. So the ones that are going to be hard are the ones that are like pi's over 3s, pi's over 6s, and those kind of things. Just do your best with those. Graphing calculators help to see the pictures. So, all right, and that's it. Good luck with your homework.